Hi everyone, my name is Vittorio Capocasale and my talk is titled The Decision-Making Framework for Blockchain Adoption. Okay, a little bit about me. My research is basically blockchain applied to logistic networks, and what we do along with my research group and my tutor, Professor Vittorio, is to basically start from industrial use cases. So we try to understand the industrial needs. We try to explore the current technological landscape to understand if there are some solutions that may fit the needs of our industrial partners. In particular, we have to distinguish between hype and real value. Then we design and implement a blockchain-based solution, and we try to provide some guidelines or some best practice from our experience. So in this speech I'd like to talk about a little bit about blockchain technology and smart contracts. I'll try to discuss why it matters and why it's gaining adoption. I'd like to discuss with you a blockchain adoption decision framework that basically we elaborate and that we adopted when we first approach our industrial partner to understand if they actually need a blockchain-based solution, and then some final thoughts on decentralization and distributed ledger technologies in general. I hope that by the end of this speech, even those of you that have never heard about blockchain before will get to know if they need a blockchain or not. So what is a blockchain? Basically, simply put, is a database with the difference that is a decentralized database. So we don't have a single entity that manages the database, or a database admin, but it's managed in a decentralized way. Just to give you an analogy, it's like if you have a wallet where you put your money and also other people put their money, and without a guardian that checks that you're only spending your money and not the one of the other people, you and the other people actually find a way to guarantee that you only spend your own money. And this is the same process with data. So we have a common database where we all put data, and we want to be sure that we are the actual owner of our data without relying on intermediaries. How we achieve this is basically by distributing a copy of the database to each one of the participants, and when someone wants to do a modification to this database, basically the participants having a copy need to agree on the operation to perform. For example, on the slide you see that at the beginning we start in the state 0. Then someone wants to do operation, wants to move the system to state 5, so we add 5. Then we, to move the system to state 3, we subtract 2. In particular, you see that we don't just update the state, but we keep track of the full history of modifications. And basically what this is important, because basically what we can do is, even if one of the participants tries to cheat or is hacked and the data it holds are modified, the system is not affected because the majority will not be compromised. Smart contracts basically are, let's say, a processing layer on top of this blockchain, which we can consider the data layer. So a smart contract basically takes as input the blockchain state, transactions, and produces a new state for the blockchain. Smart contracts are executed by each and every one of the nodes, and in this way, basically we are guaranteed that they are tamper-proof. So even if one of the copies is altered, the system maintains its consistency. So in short, we can say that we don't not have a central authority because we have a group of entities that manage a database autonomously. We do not have a single point of failure. In particular, we have many nodes, so even if one or more of them crashes, we can still rely on the remaining one. We have transparency because, which also means auditability, because we keep all the history of transactions and not just the latest value, so we can always recompute the latest value from the history in case we think that these latest values may not be the correct one. And finally, we have authenticity because in order to interact with this database, we have to digitally sign transactions, and this guarantees that we only access to our data. Why does this matter? First of all, we can think of blockchains, particularly public blockchain, as a public infrastructure and information system for the whole world. So you do not need to rely on service providers like Google or whatever to create, let's say, your own storage and processing system, but you can do this through a public blockchain. Second of all, we can create trust among the participants of the blockchain network. And this is important if you want to cooperate with others, but you don't trust them. If you want to be sure that the others do not cheat, or if you want to prove that you cannot possibly cheat. Another point is standardization, because as this data needs to be shared in this common platform, we need some standards that needs to be agreed upon by all the participants. So it implicitly pushes for standardization. And finally, through smart contracts, we can have automation, because smart contracts are basically Turing complete, so we can process and do whatever a program on a standard computer can do. The problem is that blockchain is mainly derived by hype, so we have a survival rate of the project that is less than 10%, and then the duration is average duration is less than 1 year. And the main reason is that managers, or that usually have to make the technological decisions, are unable to answer the following two questions, which are: is blockchain usable, and is the best technology to use in this specific use case? For this reason, we developed this tool that, I left there the link where you can use it on your own in case you need it. But the main questions that we think you should ask yourself if you ever want to use a blockchain is, first of all, is your system decentralized? If you don't have a decentralized system where you have multiple people having this decision and voting power, you don't need a blockchain. So go for a centralized system, a centralized database, even a distributed database, but controlled by a single entity, okay, like Mongo, Cassandra. So a distributed database, but it's centralized from a governance standpoint. If all the participants trust a third party, then simply delegate, use again a centralized database and delegate the control of this database to this trusted third party. Then do the actor trust and are willing to trust the majority? Because if you don't trust the majority, if you are not willing to accept that decisions are not based on what you want, but on what the majority thinks is correct, then you cannot use a blockchain. Then you should ask yourself if the system is balanced from a let's say, influential point of view. Because if you have one big actor that can influence the decisions of all the other ones, then you basically have a system that is decentralized in theory but not in practice. One example is if you have Amazon and a small seller, the small seller probably cannot do his own business without Amazon, but Amazon can easily replace the seller. So it is likely that if you use a blockchain in this context, you will have that it's equivalent to have a centralized system controlled by Amazon. Then is data sharing advantageous for the actors? Once again, a blockchain is mainly meant to share data. If you're not willing to share data with others, you probably should use your own separate and personal system. And there are some non-conventional ways of sharing data. For example, some documents may need to be, let's say, be protected for, let's say, 20 years and then can be shared. So in that case, you may want to store an encrypted version, for example, of the document in the blockchain and then to publish the unencrypted version after 20 years and say that yes, the two versions are actually the same because you can, or maybe instead of the encrypted version an hash, because you can compute the hash from the plain version, and so you know that the version that was stored 20 years before is actually the same of the one that is currently stored. But still, at some point you need to share data, otherwise there is really no reason to use a blockchain. Given that we want the majority to find an agreement on what needs to be done, you also want some form of incentive or mechanism to align the actors to behave according to the rules. At the same time, you want to have a mechanism that if someone tries to misbehave, they basically need to fight against the whole network. One example, Bitcoin, everyone has an advantage in producing new Bitcoins, mining new Bitcoins, because this means that you become richer. However, this also means that you are inflating the supply, and so you are reducing the value of each and every Bitcoin, and so you are reducing the purchasing power of every other Bitcoin holder. So basically you have a system where if you try to print Bitcoins out of nowhere, the others will try to stop you, and that's what makes the system work. Then you should also consider if the actors are actually autonomous, meaning that they must be able to set up their own node and to code their own smart contracts and do a proper verification, because the system works as long as the actors are independent. So you can be guaranteed that they are not relying on others. The moment they start relying on others, you have a system that becomes more and more centralized. And finally, you should ask yourself if you want to prevent proactive and retroactive data manipulations. In particular, a blockchain is able to detect if data is modified once you insert it is inserted into the blockchain. But you cannot really, but if that data is modified before, then you have no way of knowing. So, for example, if you have data that comes from sensors, you are safe when the data reaches the blockchain, but you have a problem on the sensor because you could simply move the sensor to a different place and you will get data that is completely meaningless. So all of this just to say that decentralization is actually unpractical and you should really avoid it when possible. In fact, in the current landscape, we have solutions that claim to be decentralized, but then, or that advertise themselves as blockchains, but then you see that they are fully private, so controlled by a single entity, or that they have centralization set to other layers. And so the question is, are all these compromises actually better than centralized systems? And that's a question that I leave to you because, I mean, it's more what you should ask yourself when you want to adopt a decentralized system. You should ask yourself if you really want it and if you're really ready to pay the price. So that's all for my side. In case you have any questions, I would be glad to answer.